Okay, I'm in Google Sheets, which is the same thing Excel, and I'm going to start running some regressions. I have a set of data right here. Here are my independent variables x, 2, 5, 10, and 15. My corresponding y dependent variables for 30,000 and 30,000. The way to run regressions is you select all your data, including the titles. You go Insert, Chart, and then I'm going to select Y versus X chart. I'm going to go over to customization. I'm going to scroll all the way down to the bottom of customization right here, and I want to create a trend line, linear. Once I select that, I can show my R squared value. There's my R squared for a linear function. It's 0.694. It's pretty low. So then I'll go to, I'm going to try polynomial next, showing the R squared is 0.97. It's a better fit. And then I'm going to run the third regression, exponential, and that R squared is 1. It's basically perfect fit data. So I know it's a perfect fit regression. So through a process of looking at the three R squared values, the one closest to 1 is the best fit. It's an exponential function. So I've identified the relationship. And then what I want to do here is I actually want to show the model. So I hit use equation, and there's my equation. I'll click down here, and there's my table of values. It's hard to see this here. So what I want to do is I'm going to move this to the top of the equation. And now this becomes my model. Y equals 0.99 e to the power of 0.68x. So I'm actually going to use my desktop camera and show you how to convert this into the exponential model that we're used to seeing. Okay, so here I am. This is the model that I was given right here from Google Sheets. It's an exponential model because that R squared value was so close. It was actually 1. So it's almost a perfect fit model. This E is the natural log base. So this is the number E. It's the equivalent of 2.72. You can watch my earlier video, see where that's from. The standard or general equation we're used to is y equals ab to the x. So I want to turn this into this form. So the way I do that is I go y equals 0.994. And I'm going to actually just take E on my calculator. So E is the inverse function of the natural logarithm right there. And I'm going to go, let me clear it, E to the power of 0.688. And that's the equivalent of 1.99. So this is times 1.99 to the power of x. So now it's in the form y equals ab to the x. So what I did here is I took this e to the power of 0.688x. I factored out the x, turned this into a base number, which is the equivalent of 1.99, basically 2, to the power of x. So now it's a general equation that I'm used to seeing for exponential function. Pick a few data points, plug them in for x, make sure they work for y. So there it is, running regressions in Google Sheets.